The University of Waterloo Student Housing Co-op Complex has 94 multi-residential units, each having 3 or 4 bedrooms, and some with basement living space. All the units had electric baseboard heating, and the university was finding that this was an inefficient way of heating and controlling energy in the buildings. The university was originally considering installing air conditioning to improve the comfort for residents. When they approached us, heat pumps were not on the radar as being a potential solution.
Our company has a strong track record in what I would call conventional HVAC systems. This project really showed us the depth behind RNCan's air source heat pump software tool and how it resulted in additional value to our customers and a competitive edge to us. The University of Waterloo student residences contacted us about upgrading the heating system and installing air conditioning. We knew that we could add more value for the customer and brought Dev's team on board.
About 80% of the work that my team does relates to heat pumps. And for this project, we did the design work and Brandon's company did the installation and commissioning. By using RNCan's air source heat pump tool, we took a more detailed approach and were able to show the customer that heat pumps were a better choice than standard air conditioning systems. RNCan's air source heat pump software is a freely available tool intended for anyone in the HVAC industry that's involved with sizing and selecting air source heat pump systems. The air source heat pump tool enables us to make a very objective comparison of the different models and select the right size and most efficient ones for the application. The air source heat pump tool has several high-level steps. It requires you to define the key air source heat pump requirements, the air source heat pump configuration, choose mini-split indoor unit types, define the heating and cooling loads, the geographical location for the project, and determine the air source heat pump target capacity size. Next, you can identify candidate equipment to match the requirements and shortlist choices. Then you can select the overall system control strategy to optimize costs, greenhouse gas emissions, and energy savings for the systems. And finally, you can also evaluate backup heating requirements.
Our quote was for ductless mini-split systems. With the savings calculations and modeling data from the air source heat pump tool, we were able to demonstrate to the customer that the heat pump technology was the best choice for their requirement.
We evaluated the thermal balance points, economic balance points, and greenhouse gas emissions for each of the 4 systems under consideration. We were also able to demonstrate to WCRI that the heat pump solution was not only cost-effective, but also resulted in a significant reduction in carbon footprint, which was very important to their team.
The tool was straightforward and intuitive to use, which is nice. It really helped us to convey the recommended solution to the customer and gave us a leg up over our competitors. The customer was really impressed that we included a comprehensive list of greenhouse gas reduction, balance points, and economics. This resulted in a competitive advantage for us, as well as an overall better solution for the customer.
We like the fact that the tool has historical climate data for most parts of Canada, and using the tool, we love that we're able to tell contractors about utility costs for different scenarios using different air source heat pump systems. The reality is we are heading towards achieving a net zero energy target for buildings, and the old products and solutions will begin to be phased out in the next 10 years. The fact is, the air source heat pump tool helped us win this project. It helped us to think about non-traditional solutions for supporting the customer's requirements.